Welcome to this lesson for CPI 111. In this lesson, I'm going to go over the fourth assignment, which is the creation from beginning to end of the Tic-Tac-Toe game in Chapter 3 of the course textbook. For this assignment, you are going to get a lot of practice using GML and typing in and making use of scripts. For this assignment, you can, if you wish, download a beginning Tic-Tac-Toe game file that's on the course Blackboard site. There's not much in it, because the goal of this lesson is for you to do most of the work in creating this game. But it does save you a little time by already including the necessary sprites and sounds and backgrounds for your assignment. And that's what I've got open now. I've given it a different name, but in the Chapter 13, the first thing you do if you start from scratch is you're going to create a couple of sprites. These are going to be sprites that show the game pieces for our Tic-Tac-Toe game. And there are 4 sounds: a sound for placing your tic-tac-toe piece, win sound, lose sound, and draw sound. And then there's a background image for the game. And also there's a font, a score font using Comic Sans font, which is a sometimes ridiculed font. You're welcome to change that as you wish. But that's all there is in that starter file. And starting from that, we're going to create everything else. So let's start off by creating our field object. This is going to be an object with no sprite associated with it, but it will have some scripting. So I'm going to create a new object, call it object underscore field. And then that's all we're going to do for it for now. And we're going to create our room, right? We need a room for our Tic-Tac-Toe game to exist in. So I'm going to create a room. And I'll go to the Settings tab and give it some caption and some name. I'll always leave it named room 1, but I'll call it Brian's Tic-Tac-Toe. And then go to the background tab, and we need to give it a background image, which is going to be the only background image we've got in the project, which is our tic-tac-toe background. And we'll place our only object, our field object, anywhere. You won't see it, so stick it somewhere out in the field. Nothing will happen so far because we haven't done anything, so let's save this and we will continue on. Okay. To make our Tic-Tac-Toe game work using GML, we're going to, behind the scenes, create the Tic-Tac-Toe playing field through the use of a variable. And that variable, what we're going to store in it, is going to be a 2-dimensional array. This is the first use in class of an array. GameMaker is somewhat limited in its support of arrays. It can do 1-dimensional and 2-dimensional arrays, and then there are some sort of workarounds you can do if you want to do things that are more complex than that. In our case, our field 2-dimensional array variable is going to represent the cells in the Tic-Tac-Toe field, laid out in a 3x3 grid, as shown in the course textbook. If you look at page 247, you'll see how that's laid out. Each cell within our Tic-Tac-Toe field can have 3 values. It can have a value of 0, which means the cell is empty. It can have a value of 1, which means that the human player put a game piece in that spot, or it can have a value of 2, which means the computer player placed a stone there. So let's start off by writing a script to initialize this field that will be running behind the scenes, making our tic-tac-toe game work. So we're going to create a script. Through the magic of this video lecture, here is the code for our field initiation script. We declare a couple of local variables. You can see it's local because we've got the var keyword, variables I and j. And then we are running a few statements that are commonly used to set up and populate two-dimensional arrays with numbers. So what we're doing in our case is we're going to say we've got an array that's 3 across, and to represent that we have this first for loop statement where we're initializing our I to 0, and then we're going to check to see if the current value of I is less than or equal to 2, and then if so we're going to increment that value by 1. So we'll start off at 0, and then we'll see if we are less than 2, and if so we'll do the next loop, which is going to be our up and down part of our two-dimensional array. So we do basically the same thing. It's going to be 3 spaces down, so we do the exact same check. We set our variable j to 0 initially, and then we check if the current value is equal or less than 2, and then we increment it. And then here's where the real action is. Here is our field variable, and then we have a open bracket and a close bracket, and then we have our I variable, comma, and our j variable. This is how you set up a two-dimensional array right here. You've got the name of the array, and then the spaces inside for each slot in that array. And so what we're going to do is imagine we have a field, and the first slot is going to be field 0, 0. That's the position in our array, and then we're going to give it a value of 0. And then we would move through one more time, and we'd go to field 0, 1, and set that to 0, field 0, 2, set that to 0, then this I would become 1, field 1, 0, 0, field 1, 1, 0, and so on until it loops all the way through. So that's the setup for our field initiation script. Next, we're going to create a script that initiates the game itself. And since we're going to be initiating in a game, we'll call it screen underscore or script underscore game init. And here it is filled in. In this game initiation script, we're going to declare and set a few variables: the player score, the computer score, and the number of draws. So how many times has the player won, how many times the computer won, how many times has it been a draw. And then from within this game initiation script, we're going to call out the function, the field initiation function, which is the one that we just wrote into the field initiation script. Well, we've got a couple of scripts just to set up the game and set up the field, but we haven't actually told GameMaker how to run the first of these scripts. So let's do that now. Go to your field object, open it up, and let's add a create event. And for the create event, we're going to come down to the code section on the control tab and choose execute script. And then the script that we're going to execute is the game initiation script. So since this field object is out in our room, as soon as the game starts, that object gets created and it executes the game initiation script, which in turn executes the field initiation script, neither of which actually will show anything on screen. So let's keep on moving ahead. Next, we need to set up our game so that when the player left clicks in one of the slots on the tic-tac-toe board, they will be able to place their game piece in that slot as long as the slot is empty. Now, to do that, we're going to do something that's a little bit complicated. I'm going to explain it now, but I also encourage you to carefully read Chapter 13 in the book, because you'll be able to sort of slowly walk through and make sure you understand what's going on. So in order to determine which cell in our tic-tac-toe grid the player has clicked on, we need to consider what the position is of the mouse when the player clicks in the room. And the position of the mouse is indicated by global variables built into GameMaker called mouse_x and mouse_y. The cells on our tic-tac-toe grid are each 140 pixels by 140 pixels. So, to find out whether the player is in the cell 0 or cell 1 or cell 2, we need to divide the mouse position by 140 and then round that down to the nearest whole number using a function built in to GameMaker called floor. Now this would give the right cell index if our playing field were positioned at the top left-hand corner of the room, but it's not. Instead, the top left-hand corner of the field is at the position 208 by 32, making it a little more complicated. So we must subtract that offset number from the mouse position so that we will be able to get the position of the mouse relative to the top left-hand corner of the playing field, not the top left-hand corner of the screen. For example, as it says in the book, if the player clicks at x equals 350, so they're at 350 pixels, then we're going to take 350 minus 208 divided by 140, which equals 1.01, and we round that down to 1, which tells us that the cursor has been clicked inside one of the middle columns of the cells. So we're going to have columns 0, 1, and 2. Alright, if the results of the calculations for x and y are less than 0 or more than 2, we can ignore them because it means the player hasn't clicked on the tic-tac-toe game board. However, if they're in the range of the game board, we check whether the cell that the player has clicked on is empty. If the cell is empty, we change its value to 1, meaning that the player is placing a game piece there, and then we play a sound effect. So let's put that all together in a new script called field click. And here's what that script looks like. Again, we start off with the declaration of a couple of local variables, I and j. These should look familiar. Because they're local, they'll only be seen inside this script, so we can have the exact same variable somewhere else with different values. In this case, we're going to find out what the position is that the player's clicked. So we'll set I to what we just talked about, the current position of the mouse, minus 108. Take that, divide it by 140, and then round down. And the same thing here for the Y position. The Y position of the mouse, minus 32. Take that, divide it by 140, and then round down. Then we check whether or not the player is in the field, if there is a space there, and whether or not that space in the grid is empty. So we're going to say if the player is outside of our field, so the I is less than 0 or greater than 2, j is less than 0 or greater than 2, then we just exit. We don't need to do anything else. However, if they're in the field, then we'll continue on. And we're going to check whether that position in our field is currently empty. And if not, so it's not equal to 0, then we're going to exit too. It means there's already a piece there, either the player's piece or the computer player's piece. So let's say that it's not empty. In that case, we'll set it equal to 1, meaning this is now occupied, and it's occupied by a player piece. Then we'll play the sound that goes with that, the sort of clicking the game piece in place sound. Then we're going to call a function that we have not yet written called checkEnd, and then we're going to call another function that we haven't written yet, which is findMove, and yet another script that we haven't written yet called checkEnd. So we'll have to get in and write these scripts as well. In fact, we get an error because we haven't yet written those scripts. In fact, to follow along with the order of the chapter, I'm going to comment out the call to these functions so that the script will work as it's written for now, and then we'll build up and then we'll add those functions and bring these function calls back a little later on. Now that we have a script written to do the field clicking when the player clicks with their mouse, we need to actually set up an event so that can occur. So go back to your field object, and we're going to add an event, and watch very carefully. We're going to add a mouse event, and you can see there's a whole range of events that you can choose. We're going to choose global mouse. It's important that you do this, otherwise it won't work properly. If you just choose one of these regular mouse events, it's going to check for whether or not you've clicked on your field object. And obviously the field object has no sprite, so you would never actually be able to click on it. By choosing global mouse, it will check anywhere in the room that the player clicks the mouse. And we're going to choose global left pressed. And when we do that, then we'll come back to our control action panel and choose execute script and choose the field click script. With that in place now, let's create a script that will actually draw the game pieces out onto the board. We've created a field click script so that we'll be able to check our array running behind the scenes to see if positions in the game field are open, and then let the player place or not place a game piece there. But now we need a way to actually show that on the screen. And to do that, we're going to create a new script called field draw, which I've got right here, and I've already filled it in. So this is where the action comes in terms of actually showing the stuff on the screen. The script has a couple of pieces to it. In the top part, we are checking our field array. We're just walking through it using a double loop to see if each cell within that array is either empty, or if it has a player piece, or if it has a computer piece. And depending on which version of the piece is in that array, it's either going to be 0, 1, or 2, we will then draw the appropriate sprite on the game field, either the player sprite or the computer sprite. The second part of the script then draws the score out onto the screen. We set the font and the alignment and then the color, and then we draw a line of text, which is going to be a combination of a string plus the player score, computer score, or the draw score converted into a string, and then combined together with that script, with the string. So that's a lot already. If we save our work now and give it a try, it should now work that the player can click and place a game piece in the cells on our field. So here's our field. If I click, I hear a sound and my game piece gets placed. And right now I can place them anywhere. If I click where there's one already, then I don't hear anything, and obviously another one doesn't get placed. If I click outside the game field, then nothing occurs. So we're getting there. Now the player is able to play tic-tac-toe, but of course the player wants to play against the computer. So next up, we're going to focus on creating the computer player part of the game. Okay, to start with, in working with the computer player, we need to create some scripts to test a few things. We need to find out whether the player or the computer won the last game, or if the last game was a draw. We're going to start off by checking whether or not the player did win the game. So we'll create a new script, and we'll call it script ser_check player win. And I'll just put in all the code, and then we can talk through it briefly. think for a moment what it means for the player to win. They're either going to have 3 pieces in a row horizontally, 3 pieces in a row vertically, or either diagonal left to right, diagonal right to left. So in our script that we set up to check if the player wins, basically we're just going to march through our field array, checking whether we have those, whether we have 3 ones. Remember, 1 means the player put a piece in that position. Going across, that's what we're looking at here. Going down, that's what we've got in the middle section here, or going diagonal, that's what we've got in the last section here. If any of these conditions is true, then we return true, which is going to mean that the player has won. Otherwise, if none of these checks turns out to be true, then we're going to return the value of false, meaning that the player has not won. The setup to check whether the computer wins is exactly the same, except this time, instead of checking whether we've got the value of 1 in those positions in our field array, we're going to check whether we've got the value of 2, which is the computer piece, in those positions. So we create a new script. Called script check computer win. Oof. Even saying it makes me sound like a computer program. And here is the exact same code, only now you'll see we're checking if the slot in our array is filled with the number 2 rather than the number 1. What do we do if we're going to check whether the game has been a draw, if neither the player nor the computer won? It's quite an easy script, actually. What we'll check for is whether there are any game pieces or any slots in our game board that are empty. And if none of them is empty, that means that all of the slots are filled and nobody has won. Therefore, it's a draw. And so that's what we're doing here. Again, we've got this great double loop. It's just marching through our field array, and it's checking for an empty slot. And if it finds an empty slot, it returns false, meaning it's not a draw. Otherwise, it returns true, meaning that the game has been a draw. Well, great. So we've got scripts that are going to check for a player win, a computer win, or a draw, but we haven't written a script yet to do something with that information. So we need to create that script now. And it's a little bit longer script. It's got more stuff going on. We'll call this one script check end. And I'll just stick all the code in here and explain briefly what's going on. So first we call the player check win. So we have an if statement and then we call the function. And if you think about how that function was set up, it's going to either return true or false. If it returns true, that means the player won the game. In that case, we're going to increase the player score variable by 1. We'll play the player wins sound. We'll refresh the screen. We'll pause for a second, and then we'll show a message box that says you win, and then we will restart the game by initializing the field. When we redraw the screen, what we're doing is actually making the screen refresh so that it will display the most recent move by the player or the computer and show the updated score. The next script is just the same, except now we're checking, calling the function to check whether the computer has won, and then we'll increment the computer score, play the sound, and so on. And then we check whether there's a draw. We need to call this check end script after each move by the player or the computer. So we've got most of the pieces in our Tic-Tac-Toe game now are scripted and ready to go, but what we haven't set up yet is the ability for the computer to make its moves. So next we're going to do that.